Good morning, class of 1B Physics. I'm Sinyu Yang, and today I'm going to talk about the physics of hurdles. I'm sure many of you have been to a track meet or seen a track event during the Olympics. If you have, maybe you saw the event with rows and rows of metal bars lined up neatly on the track. That is a hurdle event. Now, hurdles originated from England in the early 1800s. They would put T-shaped wooden barriers down and jump over them. However, their technique was very different than the one we use today. They adapt a technique that requires them to bundle up when jumping over the hurdles. That means that they would tuck their legs under their body and jump straight up and over the hurdle. There are many disadvantages to these primitive hurdles. For example, the wooden barriers are not easy to knock down, or they tip up and over when clipped by the hurdlers. This is extremely dangerous as the hurdlers are bundled up, and if their feet were to catch on the hurdle, they would not be able to extend their legs to brace themselves. In 1935, the L-shaped hurdle was introduced. The L-shaped hurdles are a much safer alternative because the legs of the hurdles are pointed toward the hurdler and can easily be tipped down and out of the way when they are kicked. Hurdlers also start to adapt a new technique that requires them to extend their front leg instead of tucking it under them. This eventually evolved into the modern technique. Today, in order to be fast, hurdlers must stay as low to the hurdle as possible. They will sprint to the first hurdle, taking 7 to 9 steps, then will thrust their knee up to bring their front leg over the hurdle, then bring up the back leg at almost a right angle to the body. This will help them come off the hurdle without breaking their stride and go straight back into a sprint. The hurdlers also have to maintain an exaggerated forward lean to help them stay low to the hurdle and lower the center of gravity to keep their balance when landing. This motion is known as a gliding technique. There is a lot of physics involved with hurdles. Newton's law, momentum, inertia, projectile motion, gravity, just to name a few. However, I will only discuss a couple. First, Newton's third law states that for each action, there will be an equal and opposite reaction. Hurdlers must build up speed to go into the hurdle fast, in order to come off the hurdle fast and back into a sprint. Also, hurdlers use momentum to carry them over the hurdle. In order for them to go fast over, they must use a combination of power gained from pumping arms and thrust of the leg upwards to gain momentum. This required for them to take large and powerful strides in between each hurdle to build up as much speed as possible. Beginner hurdlers often have trouble with staying low and going fast over the hurdles because they stutter step, which cause them to lose their momentum. The motion of hurdling is also an example of projectile motion, where a person will jump at a certain launch angle and land at the same angle on the other side of the hurdle. The smaller the angle of takeoff, the less time it will take to pass over the hurdle and the lower the center of gravity will be. Also, with a smaller angle comes a greater distance covered. The act of hurdling can be represented by the equations Vf equals Vi plus At, which is the vertical velocity is equal to initial vertical velocity plus vertical acceleration times time, and V is equal to delta x over delta t, which is the horizontal velocity is equal to distance covered over time. The goal of the hurdler is to maximize the horizontal distance covered to minimize vertical distance. They also want to minimize time spent at each hurdle. Increased horizontal distance velocity in combination with decreased vertical distance and time is the way to succeed in hurdles. For me, hurdling is my favorite event in track and field. I like hurdles because this event requires a lot of technique, not just speed. But as I am clearly not a very tall person, 33 inches tall hurdles can be quite a challenge. In order to clear the hurdles, I rely a lot on using my momentum, quick feet, plus flexibility. This season, I was able to compete at the conference and regional track meets and made a personal record of 17.98 seconds. These races are by far the most exciting things I've ever done in my life. Lastly, I hope this video helped you gain some interest in the amazing sport that is hurdles, or at least helped you learn some interesting physics behind it. Hope you enjoyed.